of uDig, but it can be also used standalone in the application stage. This is the link. I don't know if it works. This. Okay, this is the link where you can find stage to download. And it is really an application with all the modules there. Modules are divided in sub-packages. The first one is the ortho machine. It contains all the packages, the modules related to hydrogeomorphology analysis, raster processing, vector processing, and then the last two are the most, the latest one are the packages, the mobile, where you can find all the converter and the tools to create the maps for the background of geopaparazzi, and the LESTO toolbox, that it is the tool we developed for analysis of high precision LiDAR data. This is an overview of stage, and here we have the list of modules available here, and these are the subfolders. And inside this, you can select a module, and then in the right part of the graphical interface, an automatic graphical interface will be created. And then here at the bottom, you can choose if you want to see some documentation, very short documentation, but you can see which kind of input are required for each of these fields. Stage contains also an integrated scripting environment that usually power user uses, but it is very useful if you have to run some complex models or very heavy models on servers or so on. So let's start to show you how these tools are and what you can do with some of these tools. I just thought about some examples of tools that I can use mainly during my work. One of them is the tool for mosaic different patches of DTM, for example. It is very easy because it requires the part of the input DTM and only the output file, the all generated DTM. There is the possibility to choose between different kind of interpolation, the nearest neighbor, the linear and the bicubic interpolation. Here is an example, different tiles at the beginning, downloaded from one server. And we obtain the complete DTM for the region we are interested. And then there is another tool, that it is the raster converter. It converts between different raster formats. We now support only s.r.l, GRASS, and TIFF. Disregard the rasters. Yeah. And then another tool, for example, is the raster corrector. It allows to change the values of each pixels inside the raster. So for example, you can give here the number of the column, the row, and the new value you want to change. And in this case, as you can see, before it is all almost blue, and then I could create this pixel. It's more than one, but it's with other values. So correct and modify the raster. There are also some tools to analyze the data contained in raster. For example, one very useful is the profile. You can insert here the coordinates of the line you want to, where you want to draw the profile, or else insert a shapefile with lines where you want the profile. And then, for example, in this case with a shapefile, we have 3 lines, and then for each line you obtain a CSV, and then you can open it in a spreadsheet and draw your profile. Here, this is a mountain. and this is a valley here. Then there is one very useful tool that is almost the most used tool for in raster calculation, the map calculation. It has its own syntax, it's very similar to the syntax of GRASS. And then you can do all very lot of calculations. For example, in this case, I extracted only the pixels with height between two values, and I assigned to this a value of 1, a constant value of 1. And then there are tools that we develop for some special project. In this case, one of those is the so-called Bob the Builder, because it can help you to build some walls or some bridges or some dams, or in the other case, to erode and create holes or roads and so on. Just insert the data of the elevation, the new elevation of the pixels and the area of interest, and the tool interpolates all the pixels to achieve the desired result. In this case, we built a dam and then did some elaboration with it. So these were some tools on rasters. Then we'll see some others on vectors. The most used, we have some vectorizer for point and lines. And then there is a tool to extract the contour lines, very easy. We did also in Osaka for the field survey. And then there are the other tools regarding more or less LiDAR data are tools to interpolate raster from raw point cloud and extract features such as building and vegetation. These tools are integrated in the package called LESTO. It is an open source GIS aware library dedicated to sciences that make use of LiDAR data. And we developed these tools together with a university where Andrea is a researcher in Italy. And this is a short overview of the tools. There are different sub packages. One is for filtering, building extraction, raster, creation, vegetation extraction, filter of raw point clouds, flight lines, separations, and so on. And we will see only a few of them. For example, interpolation. The interpolation tools, the raster tools, are the one that can help you to interpolate between the raw point cloud to a DTM or DSM. There are different kind of interpolation algorithm. We implemented the adaptive tin. In this case, is applied to a digital surface model. And this is the tin associated with that. And then there are also other interpolation algorithm, maximum inverse distance, and so on. You can choose between the one that gives you the best results. Then we developed also some tools to extract features, such buildings. Building extraction gives two results. One are the blue polygons. These are the rough. This is the rough result of this building extraction. And then if you clean and if you choose to clean and optimize the tool, you obtain the second output, that it is this shapefile with the buildings in red. And as you can see here from the map, we got almost all the buildings inside the area. But since we are environmental engineers, we are mostly interested in the vegetation. So we developed much more stuff for the vegetation analysis and extrapolation of forest information. Forest information can be obtained considering two different approaches, the area-based approach and the individual tree crown approach. The area-based gives statistical data on areas of forest, and the individual tree approach gives position and main characteristic of each single tree. We work mainly on this second approach because we need the position and the characteristic of the vegetation to analyze the forest structure, evaluate the volume of the biomass, and evaluate the source of hydrogeological hazard. Some tools to extract the vegetation are the one based on raster, derived raster, interpolated raster, and it gives this result. The output is the position here in red, the extracted position of the trees, and the green triangles are the trees measured in the field with paparazzi. And here is a rough extrapolation of the crowns, very rough, only circles. And the same approach can be used also on the point cloud, and the results are similar. So in this case, if you change some parameters like the radius and so on, you get better results in the identification of the single tree. Last but not least, there is the most important package. We started with this package. It is the package on geomorphology. We have all the stuff to extract a watershed from evaluation of the flow direction, the network extraction, and the watershed delineation. Like in this case, extract the network, and this is the basin, the watershed. Then it is possible to evaluate some hydrological indexes. In this case, this is the topographic index. And evaluate the maximum discharge for a given precipitation, or if you have statistical information also from the data of the intensity duration curves, like in this case, and you have different kind of discharges. And it is also possible to evaluate the stability of the hill slope. We integrated a shallow stability model called ShallStab, and it gives the stability condition for the given precipitation and also the critical precipitation for each pixel. In the geomorphology package, we have also some tools for analyze debris flow. These tools is for the analysis of debris triggering and the propagation of sediment in the network. And the other tool is to analyze the last part of a debris flow, where it flows over a fan. In this case, this yellow is the result of a simulation, yellow, green, and so on. And the red, magenta vector is the boundary of a previous of the simulated event when it was occurred. It's pretty similar. And the last tools we integrated this summer are the tools for large wood contribute during the floods, because we have some problem of forest and rivers inside forest. So when flood occurs, also the wood comes in the rivers, and the logs contribute to clog the section where there are bridges and so on. We have problems of overflowing. So the tools were developed under the Google Summer of Code. There are pretty much, but it is a step-by-step procedure to evaluate the hazard of the vegetation during floods. And the procedure, the basic procedure is this one. We evaluate the total contributing area of each pixel, so we know the discharge and the possibility to flow in each section. Then we evaluate the widening, the channel widening, considering if there is the presence of superficial formation or there is a rock. In that case, it's not possible for the channel to wide. Then considering the stability of the hill slope near the channels, we evaluate their stability, and then only the pixels that are unstable and also connected to the river contributes also with the wood. And in this case, the wood was calculated, the available amount of wood was calculated as the difference between the digital surface model and the digital terrain model. But we will improve this tool considering the results of the LiDAR analysis. So exactly the position and the height of the trees present that we have in each of these unstable connected pixels. And then we have for each pixel the water and the wood, and then we can propagate this downstream along the network and identify the clogging section, the most critical sections in which all the logs stops and makes almost a dam. In this case, the critical section, oops, but I finished. Oh. The critical section were almost in the position where we have bridges. So this is almost a short overview of some modules we have in the Geographic Tools library. All is free and open source. You can find it to download and to use. And we appreciate if you use it and if you give us some feedback, and also if you want to contribute to any other, to any of these tools, you are very welcome. And this is just because we come back and I think we will find the snow at home. Thank you very much.
はい、ありがとうございます。何か質問、コメントが Question, any comment? あ、岩崎さん、お願いします。
And I have two questions. One is a very basic question. The stage running any platform, for example, Macintosh or Linux or Windows?
It should. It is not compiled yet for Macintosh, but there are the version available for download for Linux and Windows, both 32 and 64-bit. Not yet for Macintosh. Yeah, if you try it, yeah. Okay.
So he will try it. And another question is sometimes I asked my colleagues, there is any good software for digitizing the vegetation maps. So in the stage where uDig has some kind of the digitizing functions?
No.
No.
Digitalizing is something that has to be done in a GIS. Stage is just an environment for running models. It is not a GIS, and we don't want to do another GIS. We absolutely keep this outside. Also uDig, it's separate from this one. So in stage, you just analyze the data. It's not graphic. Okay. Thank you.
他にはありますか？はい、ではこれで、シルビアさんのセッションを終わります。Thank you very much for シルビアさん。はい、今ちょうど2時過ぎたところですけど、10分間の休憩を取りまして、16時10分から全体セッションで、14時10分から全体セッションの2番目で、 手軽に使えるグローバル地理空間情報とトポスポロジー。趣旨はこの裏側に書いてありますので見てください。